Hello, everyone, and welcome to MATHurdays. This PD is specifically is math specific, and hope you learn some great tools to use in your classroom. My name is Teresa Wells. I'm an assistant professor at George Mason University in the Mathematics Education Leadership Department. I've been teaching online for a decade now. I've implemented them in a variety of K-12 classrooms. This spring specifically, I got a chance to work with 14 Girl Scout daisies in kindergarten and first grade. So I've worked with young children as well as when I was a math coach working in the elementary schools and was primarily a secondary teacher and have a lot of experience in middle school. So I hope that today's activities give you some ideas about how to use math in a virtual setting. Um, you're going to need access to the slides. Let's see. In the chat box there, I just gave you access. If you don't already have it open, please go ahead and open that up. Our slides are fully interactive. And on slide 2 is just some general information if you are curious about what it's like to be a math specialist or try out a 100% online live synchronous classes or the whole program. There's information there. And on slide 3 are some really valuable bookmarks that you might want to add to your bookmark tabs. First of all templates are available on my website. Give me about 24 hours after this session to make sure they're all up. And all the recordings and blank, fresh, clear slide decks are available at that link at the bottom for MATHurdays. Our norms for success are on slide 4. Today, make sure you put away all distractions. You're actually going to engage just like students would, but I promise not to treat you like a young child. I'll treat you like the adult you are and all the knowledge that you bring in. We are recording, so reduce or eliminate any background noise. Questions are so important. I plan to address many of them in the session, but just in case I don't, as they come up, please type them on the last slide. And I can see we already have at least one question there. Make sure you use your mics in small groups. Your words matter, so let's make sure we're using asset language or positive language when describing kids. Mistakes happen, and when they do, if you accidentally delete something you didn't mean to or move something you didn't mean to, just hit Control Z. That will undo it. Don't drive while participating, and update your profile picture as often as you can. I've got a little shot here of my daughter and son and I were out swimming in our little wading pool. It's teeny tiny, but it works for the summer right now. And then on slides 5, 6, and 7 is a place to share our successes and celebrations. What is happening in your lives that you're celebrating today, big or small. You can add images. You can add animated GIFs. You can add links to YouTube, whatever you like on these slides. To do that, you can use a text box and then just resize it, move it around. There we go. I see them coming in now. Kim, tell us a little bit about your organization. How do you feel now that everything's all organized?
It feels really great because I felt like I had the whole summer to work on these projects, and now that it's August 1st, it feels like work is starting around the corner. So I really wanted to get done before my head was in a different state of mind.
Absolutely. It's crazy to think it's August. I still sometimes think it's March. Yes. Stephanie, it looks like you're learning a whole lot of new tech tools. I see you've put on here Edpuzzle, Book Creator, Adobe Spark. How do you plan on using them as the school year begins?
Hi. I don't know yet. I'll try to figure it out as we go on, but I thought about using them for tasks and things to get students engaged in a different way.
Oh, very cool. And nice to see you here, Stephanie.
Nice to see you too.
Let's see, we've got a lot of people are organizing right now. Whose daughter just got their permit and is practicing driving? How's that going?
That's me, Lauren. I think it's going well. Just gaining some confidence right now and figuring out what it feels like, and it's a little exciting and a little nail biting all at once.
Oh, that is definitely a major, milestone happening. So awesome. And who else is obsessed with going to teacher stores, even if it's not something we can use right away? Who's that? And what do you look forward to? Oh, it's Susan. Awesome. Um, let's see, Susie. How are you connecting with your friends?
Oh, I just wrote like a bunch of hello cards today, and so I'm going to mail them out a little bit later.
Oh, that's wonderful. I'm a big fan of snail mail. I like the actually getting them out and about. I also appreciate that. Well, folks, this is Successes and Celebrations. It is a fantastic place for students to come together. You all can even comment on other people's. So if you also are, you love going to the teacher store, you might respond to Susan's comment. You might respond with happy faces or hearts or, little images. You might also respond in text boxes. Successes and Celebrations, in my opinion, is the most important 5 minutes of your class. It's right at the beginning. Every kid gets to feel appreciated, involved, and it really helps us to get on a right foot here. So let's jump into MATHurdays. Our first activity is on slide 8. And full transparency, I am trying out a new activity here today, and I would really love feedback. So feedback in ways you would modify it, feedback in what you liked about it. But what happened is earlier this week, I was watching my kids spend a whole hour looking at two images and trying to spot the difference between the image. You might have done that before too. It's kind of like a Where's Waldo, but between two images. And then I played around with the hundreds chart and did that. I have a rising second grader, and she loved finding all the mistakes in the hundreds chart. So it got me thinking about finding mistakes. And if you come down on slide 9, come on down to there. Some of you are going to be fast scanners. Some of you will have um, an idea in mind. There are some red chips at the top, and you can drag them down to where you see the mistake on this pattern. Where do you see it? And I'll ask some of you all to go ahead and turn on your microphones and tell us the strategy you used. But today's key terms are talking about place value using the place value term. So instead of saying 9.9, we'll say 9 and 9 tenths. So practice using those terms in your explanation. Who thinks they can share with us why they selected the number they did and the mistake that was made? Go ahead and turn on your microphone or raise your hand and tell us your strategy. Rochelle, we'll start with you.
Hi. So I was in the column where I found 3 and 9 tenths. So I went down, and so I was actually looking in the tenths column where the top number is 6 tenths and 0 and 6 tenths. So I went from 0 and 6 tenths And so my eyes just scanned down 6/10 here, 0 and 6/10, 6/10 and 1 and 6/10. I was just looking straight down at the 6/10, and then I spotted 3 and 9/10. And so the 9/10 was an outlier.
Oh, I love the way you kind of scanned down the column. Stephanie, what number are you talking about and what did you notice?
So I did the same thing, but I noticed I went with the 2500s column, and I realized all of them were 2500s, and then when I looked, I realized 4 had 5200s instead of 2500s, so the numbers were put in the incorrect place value, so I realized that one was wrong.
Absolutely. And you know, it was kind of tricky with so many transparent ones, so I just moved a couple of them off so you can see that 5225. Wonderful. Lauren, go ahead.
So first I established what the pattern was across the columns, and then I kind of, I guess, zoomed out to find what visually didn't match. And so that's where I found that in the 2500ths column, that there was a shift between 4, the row with 4 and the row with 5. There was a shift.
Can you say that one more time? The row of 4 and the row of 5. And you know what? I'm going to even give you a little arrow here. I'll color it red.
Uh-huh.
Can you show us where that row of 4, row of 5 is?
I'm trying to draw it. Let's see if it works. Right here. So here's the row of 4 and the row of 5.
Neat. And how did that help you to find a chip or a space that was out of place?
So as I zoomed out, what I was expecting in the column that I was looking at, there was a pattern that just didn't happen. It was all 5s, but the shape changed. And that's what I saw before I even focused on the numbers, that the shape changed. And then I saw the numbers. Yes.
Neat. I bet you're also really good at finding four-leaf clovers.
Yeah, actually, that was a hobby as a child.
So that's a lovely thing about this is that sometimes our eyes just see the physical pattern of the numbers and the way that that changes. Who else used a strategy to be able to identify it? Karen, go ahead.
I actually had a question. So I'm looking across the top and I started looking for a pattern and I noticed that it's counting by tenths, but then after the 2500ths, after the 2/10, it went to 2500ths. So then 3/10, I expected it to go to I'm not sure. I guess I expected it to go to 3500ths and then 4/10 and 4500ths and 5/10 and because it then went again from 7/10 to 7500ths.
Right.
So I was thinking whole columns are messed up.
Whole columns are messed up. Yeah, so if we are looking at that incremental jump from 1/10, 2/10, 3/10, 4/10, then these 2500ths and 7500ths aren't following the same jump. That is a super neat pattern to notice. Carrie, go ahead.
Okay, I just wasn't quite sure if I unmiked. I thought the same thing, and then I realized it'd be interesting to kind of have a conversation and talking about this the 5/10 being the same as 50 hundredths, and then that being the pattern of like it's it goes by tenths, and then that third number goes to the hundredths place. It goes by tenths, and then the third number could go to the hundredths place, and talking about how 5 tenths is the same thing as 50 hundredths, and then it goes by tenths, hundredths place, tenths, tenths, and then talking about that whole number with the two. So 1 is the same thing as 1 and 0 hundredths.
So we could add a decimal point and more zeros behind it to show an equal number of digits going out to that place value. Very cool. All right, I do have one question though. I followed the pattern here with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but some people have a chip on 10. How come that doesn't follow the pattern? What's going on there?
It should be 10.0 or 10 and 0 tenths.
Yes, and if we had done Carrie's strategy here and put the 0.0 behind each of these whole numbers, then it would have been really obvious that yes, this is going 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. And that doesn't follow a pattern. So I'm still thinking about the find it. If anyone has any suggestions for me, things that would be different to change about it. I was inspired by choral counting, but I really wanted to like do that next step where they're actually trying to find the mistake within there and have a chance to interact with that. So I'd be very interested in any feedback you have. Feel free to put that in the chat box and I'll apply it. As a community, we can continue to think of ways that we can interact with this. Well, let's jump into our math task. On slide 11 is the purpose of why we're even doing rich tasks. I can acknowledge that sometimes it feels like we don't have enough time to do all that's on our plate, but when we follow these 8 math teaching practices from NCTM's Principles to Action, we can really make sure we're addressing our content in a way that is meaningful and that our students actually remember it through the next year. And our problem-solving oath is on slide 12. As I read it out loud, if you pledge this oath today, please type your name in the chat box. I, Teresa, promise to try my best. I will make sense of patterns and numbers. I will use manipulatives and drawings. I will make mistakes. I will ask questions. I will listen to other ideas. I will stay engaged by always trying to find another solution or representation. I am a problem solver. I make the world a better place. Oh, yay, we have so many wonderful problem solvers here today. Here is our task on slide 13. The new bestseller is here. The book publishers need to select a box for the books to be shipped out to stores around the world. The dimensions of each book are listed there, and it looks like the units they chose to use are centimeters. Design the best box for shipping the new bestseller. And there's several considerations that you should think about as you're designing the best box. Once you're in your groups, there are a couple of useful manipulatives on slide 14. Those are third-party manipulatives. And if you're looking for things like a transparent ruler, there's one on slide 15 that you can just copy and paste and put directly on top of your collaboration. And so that's available there as well. I'm going to place you in breakout rooms. Since everyone's not as familiar with Collaborate as those who use it regularly, would you just let people in your group know what room they're in? And if anybody needs support knowing what room they're in, I can pop in your breakout rooms and help you out with that. Alrighty, our breakout rooms will start in 3, 2, 1, now.
Hello, so we're on slide 17 for group 2.
Hi, we're on slide 17, you said?
Yeah, I think so, for group 2. Yeah. Okay. Wait, is that right? Group 2?
I think in order to find the information that is requested, we need to, I don't know, measure and then find the volume so we can figure out how many books it's going to fit.
I just copied the problem to put it up there because without the problem, I don't know how to make it smaller.
Yeah, that's okay. I think that's a site though, isn't it?
It is.
Okay.
It is. I don't know that we could.
I think you have to do a screenshot of whatever you build on there.
Okay.
Okay.
And then I went by 30, 15 by 30 by 2. Is that what you
No,
did?
I did 15 by 20 by 2.
Okay. Sorry.
So, but just to be able to get a reasonable answer of like how much space a book is going to take, and then so that would help us just to even start to think about it. Not everyone's going to start by estimating, obviously, but that's a good place to start, though. There's nothing wrong with that. So what we can do, because it's good to capture that thinking, like we can just draw, let's see, let me flip this around. Insert an arrow just showing like how you turned the 15 and 2500s and the 22 and 8/10s and the 2 and 2400s like into 15, 20, and I think you said 2, right?
Right.
Hi there, group.
Hi.
Hi. So I'm already loving, the first thing I heard was how you all are changing these kind of pesky decimals into whole numbers or friendlier numbers. And so my question for you is, after you design the box, what do you need to remember to account for later because you chose to round these now?
Probably like if we're rounding down, like then that means we need to give like a little bit of wiggle room in those boxes.
Neat.
See, that's why I was wondering, and I get the friendly numbers. So I'm wondering if we did 15 by 20 by 4 centimeters, that would make up 2 centimeters in the 22, and then we would only need to do a little bit more after that.
That makes sense. So do 15 by 20 by 4.
Yeah. Does that kind of make sense to everybody?
Okay.
And then that would kind of, if you look at what we left off, we would only have like, I don't know, another centimeter and some little extra change in there.
Hi, Group 7. What are you all thinking about?
One thing I did to start off with, I converted all the centimeters to inches, approximate inches, because it's just easier for me to think about it like that.
And why is that easier to think about that way?
Because that's what I use all the time. Plus, when I did the conversion, it's like about 6 by 9 by about 1 inch for an approximate size for one book. So much easier than dealing with the decimals. I also went downstairs and picked up my box that I have at home that our school math books come in and looked at the dimensions on that box. I used to be a packer for a moving company when I was in college, and I know that when you mail books, you have a box that's called a book box that's smaller so that the weight is sort of concentrated. And I was trying to think about how we used to pack the boxes when we were moving people. So I'm thinking in terms of that, it really matches the picture that you have.
Well, that is so neat that you have all this prior experience and that you found a way to make friendly numbers without rounding. Like there's a purpose to converting here, right? It's not just because my teacher told me to, it's because you're making your life so much easier.
Yes, definitely.
Very cool. Well, group, continue on with that. You're doing a fantastic job. Hi, Group 8. I'm so interested in your representation here and the numbers you selected at the top. Can you tell me what you're thinking?
Yeah, we were talking about rounding the numbers to make it easier for kind of like the guess and check kind of start, and we decided to round up because we would be leaving room for some packing also to get us closer. Yeah.
Neat. So you're going to actually use packing material kind of around the books to protect them. Is that right?
Right. Like the paper, I think it said you can use paper in the considerations.
Yeah, so there's this really cool way you can mail things using U.S. Postal Service anyways, and it's called media mail, and you get a significant discount if it's only books. Like you don't have any other crafty stuff in there. You only have books in there, and so sometimes book companies will want to use fluff like styrofoam and things, but if they do, they won't get that media discount. So it is important to try and think about how snugly you're going to put them in that box so that you don't need that packaging material. Very cool.
Thank you. Okay, great. We were also saying that we haven't thought like this in a while, so it's taking us a bit to get started.
Oh, totally. Be patient with this. Be patient with yourselves and enjoy the productive struggle. You're here because other people want to be here. So you've got a nice like open space to just think about the math differently.
Yes.
You know, next to each other, two books will fit. So,
two books will fit next to each other?
Don't you think? Because 31.2 is twice as much as 15 and a quarter.
Okay.
You know what I mean?
Yeah.
And then the width is 31.2 because it's a cube. So that will fit the longest dimension of the book, which is 22.8. So we have a couple of centimeters left, but that's okay. Nothing else fit.
So we can fit 4 books?
Let's see, how many 2 and a quarter in 31.2? So I'm using a calculator here. 31.
Hi, group. Where are you getting 35.2 from? I'm just so curious about your way of doing this.
We converted centimeters into, inch into, we converted centimeters into inch. And we figured that one of the standard cardboard boxes, like one of the smallest, is 12 inch times 12 inch times 12 inches. So we converted into centimeters, so 31.2 centimeters on each side. And that is very nice because then the book can fit right next to each other, and then we're trying to figure out how many books we can stack up.
That is so cool that you're using standard size boxes. Where did you get the information for that from?
I looked it up on the internet.
Way to use your resources. I am going to ask if there's anyone in this group who thinks that they are good at a visual for this. Can you either draw on paper pencil and upload your image, or try to use the shapes in Google Slides to kind of show us what does it look like when they're stacked side by side. That way other people can kind of see that visual representation as you're explaining it.
Okay, I can do that.
I'm terrible with vision.
So thinking about this being a pretty small book, would it make sense to like maybe almost make an array of them, like a 2x2 or a 2x3 array for the box?
Okay.
Okay.
That way you can like get a lot in the bottom of the box. I don't know. What do you think? All I'm thinking about is Amazon, where they send a tiny book in a really big box, and it's like all banged up.
So true.
And when you guys get that tiny book in the huge box, do you ever find that the corners are all banged up?
Yeah.
And I don't know about anyone else, but that does not work with my personality. Like, can you just find an appropriate sized book so that I don't have banged up corners?
Okay.
I think
So
that's fine.
this is 15, 25 hundredths a centimeter times 2
Right.
is 30 and 50 hundredths per centimeter. Okay, and then the height of it is just the length of it, I guess, is just the same.
Right, so then it would be 22.8 centimeters. Thinking about, Danielle, I think you said it, do we want a little bit of extra room around it, or do we want them to fit snug?
I feel like you need at least a little bit of extra space, right? Like I'm thinking like that we don't want.
Yeah, then you won't be able to get your fingers into even get the book
right to get them out. Yeah.
Oh, you already did that. Sorry. Can we call this, oh yeah, height of the box. That makes sense. So like that's the width, but we're using it to calculate the height. Okay. So then how big is that box, I guess, if we're really the height and the width is the only thing that you would want to getting myself confused.
It's going to be 22.8, right? Okay.
Yeah.
So if we're thinking, just, I want to make sure I'm envisioning this the same, that this would hypothetically like be the binding, right? These are the two bindings, and then all these books are stacked on top of each other. So the length is just this side of the book, but these are just stacked on, and then the height is it's going up. This is
Other way. Good question.
Does that make sense?
It does. So I would say based on the dimensions, my guess would be that's the binding, right? Because, okay.
You mean the spine?
This, right.
Yeah. So I would imagine that the longest would be the spine. So the 22.8.
Right.
For that.
So we have two stacks of books facing us right now.
So then the dimension that we don't see is 30 and 5/10, right?
I think that's still 15 and 2,500 because we haven't doubled that.
Oh, that's right.
Yeah. So actually, and with that being 15, we could get everything pretty close to 45. If that's our goal, is to make a cube. I don't know if we've decided we could get like a custom box or not.
Well, we're supposed to design our own box, so yeah, it is a custom box.
Okay.
So why would this make the best box for shipping?
Yeah, that's a good question. I guess I'm not sure if it would be better to have more books in a box. Like, yeah, I think something. I'm trying to think if it would be like cheaper to have like fewer shipped boxes, but have them be heavier and bigger.
Right. And
something.
I am kind of guessing too that maybe
this is a little bit smaller.
Right.
Hi there, group.
Hello.
I noticed you guys recently just changed your model to be 4 stacks. Tell me why you're thinking about that.
Because I have a book about the same size as you mentioned it, and I put it on the desk. And I can put 4 right on the bottom, and it seems like a very nice, good box to handle.
Very cool. So you used your resources from home to help you see that.
Right.
That's so cool. Love it.
So I'm estimating everything in.
So now we have a box that's
All right, at this point, I move myself in the main room so I can have some quiet time to think about the order of what I'm doing. I would like group 1 to show us their kind of double stacking that they have here, because that is the base, and they're going to find volume by taking that base and stretching it in height. That's similar to group 8's, where they are also finding volume, but in terms of number of books, and they only change one cell. They change the width, and that in turn changes the number of books. So again, we've got another one where one dimension is changing. Before it was the height, this time it's the width. And I want to talk about why we only change one dimension at a time. The group 3 started off with 2 books, and then they changed it to 4 books. And I'm curious if other people can make the connection about changing just one dimension. All right, it's time to bring everyone together.
So if we say 5
Hello,
books,
everyone. Welcome back.
what is the size of the?
We are all back together now. Can you believe you've been working on that for 20 minutes already? I'm going to go ahead and mute your microphones just so we don't talk all on top of each other. And also, that's the way I show respect for your background, that I'm not intruding on that. It looks like most mics turned off automatically, except for Kathy and Marcy. If you can just double check that your mics are off. Excellent. And let's talk about this problem and all the different math standards that could have been incorporated in this problem. But we're going to start off on slide 28. I've selected just a couple to go over because I have one specific mathematical objective to get to today. And that all starts on slide 28. So slide 28, they have this lovely sketch of two pieces with the yellow arrow. And group, can you tell us what do those two rectangles represent?
Those are two books laying down at the bottom of the box.
Oh, lovely.
And yeah.
So there are two books laying down in the bottom of the box. And then how does that help you with this prior knowledge that you all were able to establish up here? Tell us about the average size and how that relates to this here.
Well, we looked up and it looks like that cube box, it seems to be the standard box to send books. We're just making a lot of assumptions, but we decided to use the box.
And this 12 by 12 by 12 box relates to the choice you made about stacking two books, right?
Mm-hmm.
Tell us why you chose to do that.
We converted so the dimension is right here on the top, and we converted that into inches, or we converted the inches into centimeters, and then realized that it's really nicely fit if we choose this box. So we decided to use this box dimensions.
Wonderful. So if you're using this cube and you did the conversions, two books side by side, that 15 1/4 fits so nicely. Isn't that amazing? On slide 29, another group did something similar in terms of stacking. Let's come down to slide 29 for a moment. And can you all tell us how you're thinking about the table on slide 29?
We started with a representation with the picture on the right, and then also added in, it was kind of cool to have, you know, I'm a visual learner, someone else was working with the table, made more sense to them. So using the table allowed us to kind of match what was happening in the picture. Let's start with 10 books. Let's think about how bookstores might order books in groups of tens. So starting with what would that look like for 10 books? What if we added another, you know, group of books next door in the same position? What would that look like? We didn't get to finish our thinking, but that's where we started trying to get to what would this look like in a box is where we were headed next.
Wonderful. And so if I understand right, it's as if we have the 10 here and the 20 over here.
Yes.
Awesome. All right, here's the question for everyone else. What dimension are they currently changing? Who can tell us how you see it? What dimension are they changing? Excellent. They are changing the width. And as they change the width, what also changes? Can someone turn on their mic and explain to us what happens when they change their width?
Changing the volume.
And how do they measure volume?
Length times width times height.
So yes, that is a formula for how we measure volume, but how did they measure volume? How did they report out their volume? Anyone can answer this one.
So, yeah. I was going to say their volume is really the number of books.
It is. So their units are books. And yes, as the width increases, the books increase. And I know some of you guys are really wanting to get into the multiplicative property there, but we're simply going to look at one dimension at a time and seeing the way that changes. Come on up to slide 28. Who would like to share with us what dimension is changing here and what that results in? This one's a little tricky. Let's get a little more group knowledge before we answer that question. Come on down to slide 30. On slide 30, they started here and then moved to slide 31. What I'd like to know from your group is why did you make this shift from slide 30 to 31 and what changes?
Yes, so there's a person in our group who had a book around the same size of the dimensions that were given for this book. And so based off of that size, he laid it down and looked at the four across, seemed like a decent sized box. And because the books are a little bit smaller, that seemed like it could still fit in a box and it would be a reasonable size. We hadn't gotten to fully getting the dimensions, and that's what we are working on then, but we are just trying to figure out what is the best size box to hold these books, knowing they are a bit smaller because they're in centimeters. So we're using the ruler to help us gauge kind of the size of the books stacked on top in the box as well.
Wonderful. Now, I've heard in the chat box and over voice, many people were talking about this idea of length times width times height. How does that relate to slide 31 in their image? What's the length? What's the width? What's the height?
You talking to me?
Oh,
What?
anyone. This is nice and open. You can write in the chat box. You can use your mic. What's the length? What's the width? What's the height?
Not a good idea. He's gonna get hurt. I don't think it's fair to.
Well, the height is a stack of 10 books. Like, if you stack the 10 books on top of each other, that's going to be the 22.4 centimeters.
Oh, wait, I just heard two things. I heard it's 10, and then I also heard, what was the other number you used?
The 20, well, I said 22.4, but 22 and 4/10 of a centimeter would be the height if you did a stack of 10 books.
Okay, so we have 22.4, and what was the units for that?
Centimeters.
All right, so these are both the same thing. You could say 10 books, or you could say 22.4 centimeters. What about the length or the width? Who can tell us what you would use for that? Oh, Lauren, tell us more about this.
So what I was looking at is the measurements, and that's a more complicated thing to talk about. But it's really easy to say that the height is 10 books, so it's 10 books deep, and they made 4 stacks, so that's 4 stacks wide, and the distance from the let's see, then each stack is the size of one book. Does that make sense?
I'm kind of losing myself in my thinking about it. But
you are making a lot of sense, but I think we could use somebody to rephrase that for us.
Okay.
Who thinks they can rephrase that? Lydia, would you mind telling us a little bit more about what you just typed in the chat box?
I think Lauren just changed the units from centimeters to bucks.
Neat.
So in terms of how many books you're going to have in length, width, and height, it's going to be one book width, or I don't know how to say that. One book length, 10 books high, tall, high, and 4 books deep, kind of thing.
And if we were talking about volume, now I know you all put in length times width times height in the chat box. If you were to put in volume, what are answers that would be correct for this problem? Go ahead and type them in the chat box. What would be some correct volume calculations? All right, so we had people that multiplied 10 times 1 times 4 and got an answer of 40. What other calculations could be correct other than 40? So we have one number, which is 40. What's our other number?
$120 centimeters cubed.
How did you get that?
Because that's a good question. It maybe 160. I'm thinking 4 stacks because the 40 I was thinking is just the volume of one stack of 10.
Oh, so let's figure out what the 40 is. Laura, you wrote 1 times 10 times 4 equals 40. Can you give us some units to that? Can you tell us like what you're thinking the 40 means?
Probably like the 40 would be like, if we're thinking the units are books, they could books.
Cool. And notice this isn't books cubed, it's just books. That's weird. I thought volume always had the cubed. Anyways, so we have volume equals 40 books. And we've been talking about other units today. We've talked about how we can figure out volume by books. And we also have another unit on this slide here. What's the other answer for volume? And Lisa, can you tell us how you got yours solution?
I just multiplied the 3 measurements, the 3 dimensions to get almost 779 cubic centimeters.
Oh, well, that's
I think
cool.
as far as shipping costs, I think they're going to use cubic centimeters as opposed to books. So if you're worried about shipping costs.
Neato. So we have volume, and we've responded in volume in terms of books and also in terms of centimeters cubed. And as we were to go back up to slide 29, who thinks they could add our other unit here next to our 20 and our 10? How could we figure that part out?
Can you repeat that question again?
Yeah, so on slide 31, we had 2 answers in terms of volume. Our volume was 40, and our volume was also 778. On side 29, they also talk about volume. And they give a volume of 10 and 20. What are the other measurements that are not seen here?
The cubic centimeter
The
volume.
cubic. Who thinks they can fill that in? If you've got it, go ahead and add it to our table. And I see some people are starting to type in there. One of the major misconceptions or conceptions that I wanted us to explore today is so frequently as a math teacher, I am really trying to stress the importance of using units with my students. And I always stress the importance of cubic units for volume. But one of the things that this task does, it allows students to move comfortably between decimals and whole numbers. So if they want to use whole numbers, we can measure everything in number of books. Those are whole numbers. When we find the volume, it's not like they're books cubed. They're still just books. However, when we go into dimensions, we have this idea of length times width times height. And when we multiply them, we get this cubic volume. And one of the things I like to have my students grapple with is, when do units matter? When do you have multiple correct answers? And when do you bother with putting on this whole cube situation? And I hope that in today's activity, not only did you get to play around with decimals, but you were able to play around with this idea of volume. And does it mean the area of the base growing taller? Or does it mean you have a box like on the slide 30 to 31, and now you've stretched this box longer? In each of these examples, we did kind of play around with volume and changing one dimension and how it affects others. As a follow-up lesson to this, I'd usually have my students see what happens if we double all the dimensions, because it's not intuitive of what to happen here. But anyways, folks, this is one problem. I hope to have showcased that decimals doesn't need to be its own unit. You can talk about decimals in your geometry unit. You can talk about decimals in your measurement unit. You can talk about decimals in just about everything, and it doesn't need to be its own section. So folks, that was today's session. If you see this working in multiple grade levels, go ahead and add that to slide 35 and 36. So if you see a part of this that could be done in 3rd grade, tell us. If you see a part that could be done in 8th grade, tell us what it is. And if someone else has the same box as you, just move to another box. And Aline wrote in there, it's not intimidating to use books as a unit, and that's one of the reasons we start with non-standard units in primary. We measure things in terms of paper clips or cubes, and it does take out that weirdness about what units do I use, and are they squared and cubed, and what does that squared and cubed even mean? All right, folks, that's the end of our hour. I hope that you can use some part of this problem in your classes, whether you're teaching summer school or in the fall. And if you do, if you have any student work, of course their name's taken off of it, that you would like to share on social media, use the hashtag MATHurdays, and let's see all the ways kids think about this. It's been a pleasure, everyone. This is always my favorite part of Saturdays, and I'm going to spend the rest of the time down at the virtual parking lot answering any and all questions you might have. And there's even more slides below, so ask away. Alrighty, the first one, how do you make the background transparent, like your celebrations and parking lot? I have several videos on my website that are really frequently asked questions. So first of all, I'm going to link the main page. Frequently asked questions. Here you go. Those are videos of it. But what I'll also do is link your specific question. So you wanted to know the transparent backgrounds. And that's kind of like locking your slides. It's an image. And what I'll do is I'll just hyperlink your question. And you can click on that and watch the video answer. And folks, there is more room on slide 39 if you'd like to put your questions there too. Do you have any tips or resources you can recommend for asynchronous online teaching? In the spring, we're only allowed to meet with our classes 1 day a week, and I'm afraid it will be similar in the fall. No specifics on that yet. One of the tips that I would do is if you plan to do a rich task like today's, let students kind of play around with the problem ahead of time and submit to you their work that they're thinking about. And then when you have all, let's say, 25 pieces of student work, you can take that work and purposefully group students for your synchronous session. So like if you were to give this problem and you saw that 4 groups of students were thinking of stacking the books in the same way, you might group them together. If you saw folks that were unitizing by books, you might stack them, put them together in a group. If you saw folks unitizing by centimeters, you might group them. And so you do get that kind of one step ahead in the rich tasks because you can group them by either similar or different strategies, and that will really show up in your class. I also like doing any kind of procedural mathematics learning through video. I often think, just like these frequently asked questions, video is less rambling and more specific about exactly how to do it, and that saves your synchronous time for really collaboration. So those are a couple ideas for you. How do you address the issue of students who are calling into class working on an iPad and can't go back and forth? Oh, so they actually can go back and forth. I have a video that shows how easy it can be right here. So the trick here is you really want them to download the Google Slides app. That is super important in making sure that they can edit. How did you make your dots transparent in the Find It activity? Ooh, I'm really excited to show this. I frequently use transparent things, but only recently I realized that it's kind of a little bit of a hack and maybe other people should know about it. So I've created a little video here that shows how to make things transparent, and I'll link it for you here. Finding rich math tasks. A lot of the ones that I use, I am thinking about them all week long and how to delete information out. However, you might check out various books. There are 3 books out recently through Corwin called 5 Practices in, is it in Action? Hold on. It's Peg Smith's new series, In Practice. There are grade specific, and there's little videos about how to use those in session. You might also check out Mars and Rich and Engaging Mathematical Tasks. There's a couple books, and Mars is a website that you can check out as you're developing these. Yeah, the slide deck will be available after today at, let's see, they'll be at the MATHurdays link. There we go. So I went ahead and linked it. They'll be available later on today. All right, I've struggled using virtual manipulatives in each of the math days I attended. What resources do you recommend that I can use to research this? Um, Yeah, I absolutely could do one on how to use online manipulatives. What I find that I like to do is, even with students, is throw out lots and lots of ones that they could use and give them some exploration time first. This is something I would have done in the face-to-face classroom anyways. If I have a new manipulative, they're going to get some free time to just explore it. And I do the same thing online. Here's the difference. Online, I keep a record of when I see students showing mastery of that manipulative. So I can say, if someone's like, I don't know how to use this, I'll say, well, Laura does. Why don't you connect together? And Laura, can you explain to Henry how to use that manipulative? And I have the students do all the work for me because I'm looking out for other things like what students are doing mathematically that I don't want to get into the tech part. So giving them the time to explore the manipulatives makes them leaders and, gives them more time. Let's see. How do you decide in the moment how to balance between calling on students and summarizing what you're seeing in a virtual environment? Who was that? Can you explain to me what your question is about? I'm having trouble relating that.
Yeah, that was me. I'm Kelly Lynn. So one of the things I noticed is there were times where you asked for the students or like us, the participants, to answer, but there were also times where you just summarized what you were seeing as opposed to asking someone else to kind of summarize. And I wondered how you made those decisions because it seemed like it might be different here than maybe that same balance in a classroom. So I was just wondering if you could share kind of like your thinking so that we can learn from that.
Yeah, absolutely. I have an image that I'm going to upload real quick. I always make a strategies map, a way that I'm thinking about how all the different strategies relate to one another. And I use that for the basis of my discussion. What I'll do is I'll do a new slide below. And I'll insert my strategy map. So these are just some kind of in-the-moment decisions that I am trying to make on slide 40. I really wanted to address the idea that we can find volume by stacking area. That's something that my students definitely struggle with, the idea of what dimension do I increase. And so I've got a little note what dimension is changing. And then group 8 had this like as one thing increased, the other one increased. And that was how you would use to find volume. Again, just changing one dimension. And what this group also did is they talked about unitizing to books or centimeters. And then in group 3, I was really looking at how do we change one dimension again, but they had the full stack. So they already had the idea of length, width, and height, but they're changing how many books in a row, whether that's 20 books or 40 books. And so I wanted to bring that one up. And this was kind of my big question of why do we only change one dimension at a time? But, strategy maps are only as good as the conversation goes. I realized in this that we needed to talk more about the units of whether it's books or whether it was centimeters. So I did kind of change a little bit of the mathematical objective there when I saw that need. And I sometimes do that with students. What I do at the end of a unit is, or an end of a rich task, is I look at my original math goal that I intended, and then I go back and I say, what is the mathematical goal that I actually accomplished in class? What did students actually learn here? They're often related, but they might not be exactly the same. And so I use that to either say, hey, well, I've already hit this in a future unit, or I need to go back at this rich task when we hit the single dimensions later on and have another discussion on the same problem using the same student work so I can really address this math concept. In terms of who talks, I wanted these objectives to be said, and I'm hoping that they're said by students, either in the group or the whole participants. But if they're not being said, then I'm going to explicitly say them. Um, in a class, I explicitly say things more often at the beginning of the year as I do gradual release to get my students to be the ones to say that. So, I'll ask them to rephrase it in the chat box, rephrase it using the microphone. And if I'm still not seeing it quite there, I will explicitly say it until they've gotten used to it enough that I don't actually have to explicitly say it. They're able to say it on their own. I know that was kind of really long-winded, but I highly recommend reading the 5 Practices book. This is not my ideas. Smith and Stein have been doing this since the early 2000s.
No, thank you. That was really helpful. Because I could see the 5 practices and I wondered if there were differences in the virtual environment, but you clarified. So thank you very much.
Yeah, sure thing. Yeah, I'll be providing PD throughout the school year. When new needs come, I kind of change the PDs. As long as, people keep attending, I'll keep offering them. There was a lot happening in today's task. Could you clarify the content goals of the problem? Yes. So much like Kelly was mentioning earlier, my content goal today was to talk about volume, units, and conversions with K-12 teachers. And that is a little different than the topic I would be doing with students. I really wanted you all to see the ways that you could take this problem and stretch it across multiple grade levels. With students, I might get more specific as to what happens when you change one dimension, and it will change one of the other things like volume or another dimension. I want them to see that direct variation. As one goes up, the other goes up. This would be front-loading a later activity of what happens when you double all the dimensions. Well, it doesn't actually double the volume. It does something more. And so that might be the objective of today's if I was working with K-12 kiddos. Students at my school might need support with the context for today's task. They're familiar with the school library, but probably not been in a bookstore. How would you build background knowledge for the problem? Oh, so in the virtual world, we have access to one of the best sources for prior knowledge, and kids love it. It's called YouTube. I would go on YouTube and look and just kind of search for videos about people kind of going through a bookstore or actually stocking the shelves, pulling the books out of the box and putting them on the shelf in the bookstore. Another thing is, depending on the tech skills of your students, just asking them to go off and, for homework, find a YouTube video that shows how you take books out of a box and restock the shelves. And then they're the ones creating the knowledge. They're the ones going out and finding it and bringing it in. I think I got to all the questions in the virtual parking lot. What other questions do you have? Feel free to use your microphone. I'm happy to answer them, and probably have done something similar. Carrie, go ahead.
So I was just thinking in terms of like setting this up with students as they start to problem solve. Like, how do you ensure that like all students are sharing? I know you mentioned like giving them the question ahead of time and then picking and choosing, but like in this group, like I was wondering, like, do you have protocols that you use to make sure students kind of each share an idea versus sitting back and listening? Like, what are some of the things that you do management-wise to make sure that, like, all students are participating?
Yeah, so I use a student observational checklist during a unit, and the list might just have student names down the first column, and then objectives as the column heads. And when I see, today in our lesson, Janet was able to verbalize the way volume changes when one dimension changes, and I just put a check next to Janet's name, whether that was verbalized in a small group or in a whole group, because I've observed mastery of that. And as my unit continues, I might see that this whole time that Teresa has never verbalized any of these 3 objectives in this unit. So then as I'm working with groups, I'm really going to focus on asking Teresa those probing questions and making sure that they're able to verbalize that as a way of me checking for understanding. So I really just use check marks. It's so much easier than is so many of the other things that I've tried. So that's the way I do it with kiddos.
Do you do professional development online for schools and teachers?
Yeah, so I do lots of free PD sessions. I do them daily, and then schools will sometimes contract me out, and I'll do private sessions with them. You can email me if you're interested, and I'll give you quotes and all that good stuff.
Okay, thank you.
Yeah. All right, folks, if that's everything, then happy Mather Days. Go off, have a wonderful weekend.